Use the principle of a minimum potential energy to formulate equilibrium equations of a spring system shown in figure. So step 1 is identify the elements. Here element 1, element 2, element 3 and element 4. Then after, and K1 is the element stiffness matrix of element 1 and K2 is a stiffness matrix of element 2. Similarly K3 and K4. So and U1, U2, U3 is the nodal displacement of the elements. Okay. Then according to the questions, the minimum potential energy here for the total minimum potential of the energy here have taken pi, but actually potential, as we know, potential of the energy PE is equal to half mv square. That is the m is mass and b is the velocity, but here in terms of m they have taken k1, that for the element 1, and the k2, k3, k4 similarly. So here is a pi is equal to pi is equal to total principle of the minimum potential energy is equal to half k1 then u2 minus u1 whole square. This elements k elements, first elements is starting from u1 to u2, so here is a final velocity minus initial velocity. So here is a final nodal displacement minus initial nodal displacement plus similarly k2 is equal to half k2 u2, here is only u2 that is given in the question, plus half k3. In k3 there is it is starting from the u2 but finish it u3, so that's why final minus initial here is square, so that is the u3 minus u2 whole square plus then k4 is only u3, so half k4 u3. Then after that don't forget to write the force. Here is a force. You write minus f1, here is u1, f1 minus u1, then minus f3 into u3, but actually in the spectrum there is given f2, that is wrong. How to form a force here in a nodal displacement of a u1? The f2 can form only here f2, but here can't form f2, but question they have done a mistake, f2 here. Here only three equations are satisfied, d pi by dou u1 or dou pi by dou u2 and dou pi by dou u3, because here only given u1, u2, u3, that's why only three equations are satisfied in this questions. Okay, so what is pi? Pi is equal to principle of the pi is equal to principle of the minimum potential energy equations pi. So here d pi dou u1 pi is equal to what is potential energy, half k1 then u1 minus u2 minus u1 whole square for the element 1. Then after that what is there is also given force now, so that's why minus f1 into u1. Pi is only as we have taken u1 for the element 1, so we should find whatever given in the element 1, that also we write here is equal to 0. So different with respect to u1. Okay, so that is a half is taken common, so this is a x power n formula. So I think you know d by dx of x power n is equal to nx, that is here this is x and this is n, here into 2 into k1 u1 minus u2 minus u1 minus of then also internal derivative. What is the internal derivative? Here u1, so u1 here then as you know d by dx of x is equal to 1, so d by d of u1 internal derivative u1, but here is a minus, so that's why you multiply minus 1, then minus of f1 taken common, then d by dx of d by d u1 of u1 is equal to 1, so is equal to 0. Then this will be cancelled, then k1 is equal to u2 minus u1, here is a minus 1, then minus f1 is equal to 0. Then after that it will be minus k1 u2 then plus k1 u1 minus f1 is equal to 0. Similarly for the d dou pi by dou u2 is equal to, for the element 2, that is element 2, what is given? Element 2 is connected, that is connected. You can see this is element 2, this is connected with the k1 and also connected with the k3, so that's why is equal to half k1 u2 minus u1 whole square plus half k2 and k2 u2 then minus half also connected element 3 now, so that's why k3 then u3 minus u2 whole square. Similarly d by d of u2, similarly it will be like k1 u1 minus u2 and here d u2 of u2 is equal to 1 into 1, then plus of half k2, yes, half k2 u2, yes, half k2 u2, and here is square, don't forget to write square, so into 2 also, so half into 2 get cancelled, k2 u2, then plus you don't have place to write, so that's why k3, and here it will be 1 into 1 here multiplied, okay, k3, then here u3 minus u2, then minus of a minus 1, because here u2 that is connected with a minus, so minus of a minus 1, so okay. Similarly here you will get a minus k1 u1 plus a k1 plus k2 plus k3 u2 minus a k3 u3 is equal to 0. Then consider equation 3, that is a d, you can call that d or do, okay. So here is a element 3 is connected with the element 3 and the element 4, okay. Element 3 is connected with the element 3 and element 4 and also element 2. Sorry, this is connected with the element 3 and element 4, it is not connected with the element 2, so it will be d by d half k3 u3 minus u2 whole square plus a half of k4 u3 u square minus, and also it is connected with a force, so don't forget to write force, okay. f3 u3 is equal to 0, so you will get minus k3 u2 plus k3 plus k4 of a u3 is equal to f3. f3 sorry, here f3 is equal to f3, otherwise you can write minus of a f3, okay. So then after that find the writing the equation 1 2 3. So already we have written, this is equation 1, this is equation 2 and this is equation 3, then 1 2 3 in terms of matrix, write in form of matrix, okay. And this is nodal displacement is given u1 u2 and u3, and here it will be write in form of a k, this is u is equal to f, write in this form, okay. This is f1 then 0 then f2. Here it will be k1 then minus k1 then 0 then minus k1 plus k2 plus k3 then minus k3 then 0 then minus k3 then k3 plus k4, okay. So okay, this matrix is came from the equation, this came from the equations what we made 3 equations, that comes from that, okay. Here is a, okay, so here is a u1, in the u1 place there is a k1, and here that is a u1, then here is u2 and here is a u3. So in u1 that is k1 and u2 there is a minus k1, then after that 0, okay. f1 here is minus f1, if you take right side it will come plus f1, okay. So similarly for equation 2 u1 is a minus k1 and u2 is a k1 plus k2 plus k3 and u3 is equal to minus k3, and similarly from the equation 3 here don't have u1, so that is 0, and u2 is a minus k3 and u3 is equal to k1 plus k3, okay. So as we know in the question there is given f1 and f3, so that's how we have written here f1 and f3. So here is a for the f2 we have taken 0, because in the question there is not given f2, so that's why we have taken 0, and so cancel that row, that is a cancel that row, similarly cancel that column. So what you have k1 0 then 0 k3 plus k4, and then here is a u1 u3 is equal to f1 f3. So it will come like a k1 sigma 1 is equal to f1, and it will be k3 sigma 3 you can write sigma 3 or else you can write u1, okay, minus k4 sigma 4 is equal to f3. Your wish how you will write, okay. Here sigma 1 is equal to u1 minus u2 and sigma 2 is equal to u2, sigma 3 is equal to u3 minus u2 according to your potential energy, and they are don't given sigma 4, so that's why here taken u3 minus u3.